we're trying to prove the beta function, right? So this is section 6. And we're trying to prove that b of pq is equal to the integral from 0 to infinity of y to the p minus 1 dy, no, over 1 plus y to the p plus q. Yeah, well, originally we have, we know what the definition of the beta function is. Beta of pq is equal to the integral from 0 to 1, no, x to the p minus 1, 1 minus x to the q minus 1 dx, assuming that p is greater than 0 and q is greater than 0. Yeah? And yeah, what you could do, I mean, this is a fairly simple substitution. You can go to this definition here for the beta function to prove the above formula. And you can say, you make the substitution x equals y over 1 plus y. Okay? And now you could turn this around. So we're going to plug that back into the red definition of the beta function, yeah, in red. Yeah, and we just have to find what dx is. So differentiate. So you get dx, quotient rule, 1 times 1 plus y minus y over 1 plus y squared dy. So this turns out to be, the y cancels the y, and we get 1 over 1 plus y squared dy. So you can replace dx with this. Now let's do the bounds. Again, we have to change the bounds. If x is 0, then y over 1 plus y is equal 0, which makes y equal 0. And if x is 1, that means 1 equals y over 1 plus y, which makes 1 plus y equals y, which makes 0 equals 1. Is that true? No, so that means it blows up at. It's false for x equals 1. Right? Okay, so that means, I mean, unless y is infinity. If y is infinity, then 1 plus y equals y, because then 1 is negligible. So then this bound has to be infinity for this to work. For 1 plus y to equal y, no? Okay, so now plugging into the definition of the beta function, we will get beta. Let's use this red. Equals. Now the bounds are 0 to infinity, and x is y over 1 plus y. Right? So I replaced x with y over 1 plus y, p minus 1, into 1 minus x is y over 1 plus y, q minus 1, and dx is just 1 over y plus 1 squared dy. And now it's a matter of cleaning this up. So if you common denominator here, you will get 1 plus y minus y becomes 1 over 1 plus y. And each one of these is raised to the q minus 1. But 1 to the q minus 1 is 1. And here you have y plus 1 squared. And here you have y to the p minus 1 over 1 plus y to the p minus 1. Okay, this is equal to the beta function. And now what I could do, I could combine all of these together because they're all the same. So we would get beta equals the integral from 0 to infinity y to the p minus 1. Just add the powers. You have p minus 1 plus q minus 1 plus 2. So the integers go away and you get p plus q. So you get 1 plus y to the p plus q dy. This is the desired result. You see, it's just a basic substitution into the gamma function, the beta function.